Hey, hey, hey. Okay, this recording is designed to help you with the chemical control of microorganisms. So, part two, the first one was physical control. So the first one is phenols and biphenyls, and we talked about this with, on the first exam with Joseph Lister. He was the first guy to use aseptic surgical techniques. Remember this? And he used the phenols, and he would have them. The doctors and nurses would wash their hands and then soak the patient's wounds to kill organisms, and he drastically increased the number of patients who survived surgeries. And in fact, I want to say the first time that abdominal surgery was ever performed. And so derivatives of phenol, which are rarely used because they're irritating, so they irritate the skin. Phenols remain active in the presence of organic compounds, so active in the feces or stool or active in the blood. Okay, so you want to know some examples. O-phenylphenol, that is Lysol. So that is a derivative, a version of phenol that is less irritating. Okay, used in coal tar. This is used to, it used to be used, it's not anymore. It used to be used to preserve power poles. Cresol, it was a chemical that they soaked these power poles in so that they didn't rot. However, it was irritating. So my husband works on power lines, and he says that if there's ever a pole that has this in it, the skin is itchy and red and all that. Hexachlorophene and triclosan, those are like widely used in body washes, but not so much anymore. Triclosan has been banned from some products. So, but look at the back of your body wash and detergent and toothpaste and things like that, and see if triclosan is in them. It's widely used in body wash. Okay, this is just a picture I added in from the book. So it talks about Lysol and then the biphenyls. It just shows the elements. Okay, so this is what we're going to do in lab, the chemical portion of lab. So we're going to take the bacteria and spread it out on the petri dish, and then you're going to take a filter disc, a little round piece of filter paper, and soak it in a chemical of choice and kill the bacteria that way. And so we're going to see, if you look here, so we'll see hexachlorophene, for example, did not work at all on Pseudomonas or on E. coli, but it worked well on Staphylococcus aureus. And so you can see the difference there as far as if it worked or if it didn't. So when there's that ring around it, that means that the bacteria did not grow up to the chemical. This is that disc diffusion method that we'll use in lab. Halogens, think about the periodic table. They were right in a row, the halogens were. So iodine, you know, the brown iodine. Chlorine is often used in swimming pools. Bromine is oftentimes used to clean water, so drinking water. And fluorine, which we use fluoride in toothpaste, right? Bleach is a hypochloric acid, so it's made of a chlorine. So those are some examples of halogens: iodine, chlorine, bromine, and fluorine. So these are just examples of different chemicals that we can use to reduce bacteria. So disinfect. Let me mention bleach for Clorox. Write this in, the recommended number for Clorox bleach. Now, you know, let me mention that Clorox is a brand. So I should have said bleach instead right there. Is 10% bleach, 90% water. Okay, alcohols, we're talking ethanol and isopropyl alcohol. The recommended concentration here is 70%. So you wrote it in for bleach, it was 10%. For alcohol, if you look at the hand sanitizer at the hospital, it's 70% alcohol. So 70% alcohol. Most of the bacteria actually comes from rubbing your hands together when we do like hand sanitizer Germ-X. It denatures the proteins in the bacteria and dissolves the lipids. Heavy metals can be used as a disinfectant. And so mercurochrome, copper sulfate. Okay, so you want to know this for sure. Silver nitrate used to be used in newborn babies' eyes. Now we use a antibacterial petroleum, but like an antibiotic, erythromycin. But used to, initially, they put silver nitrate drops in newborn babies' eyes to prevent blindness from gonorrhea. If the mother has gonorrhea, when the baby comes through the vaginal canal, the gonorrhea organism can get in the baby's eyes and cause blindness. And so this is a federal law now that all babies, all babies have a disinfectant initially it was silver nitrate, put into their eyes to prevent neonatal ophthalmia by gonorrhea, so blindness, newborn baby blindness. But you want to know that silver nitrate drops were put in to prevent blindness from gonorrhea, but the law is not just if the mom has gonorrhea. The law is for all babies, not just infected moms. Okay, gaseous sterilants. So these are sterilants. Remember what a sterilant is. A sterilant kills everything, even endospores. An ethylene oxide, very effective. Most hospitals have an ethylene oxide chamber. The problem is that the gas is carcinogenic, so they have to let it filter out before you can actually enter in to get the things that have been used in an ethylene oxide chamber. So they would use this for things that can't go in the autoclave. So instruments that are sensitive to heat or pressure can't go into the autoclave, so they use the ethylene oxide chamber. It is used to sterilize objects sensitive to heat. Okay, you want to know that the petri dishes that we have in lab, they come in this plastic bag that was sterilized in a gas sterilant in an ethylene oxide chamber. Ethylene oxide chamber is used to sterilize our petri dishes. This is just a picture I took out of the book, so you don't have to know this picture by any means. Don't memorize this. But it's just talking about what is most resistant and what is least resistant. And so it talks about, you can see that endospores are among the most resistant. So we've talked about that. And then gram-positive are least resistant for chemicals. So you don't have to memorize this. I just thought it would be interesting to look at. Again, a table out of the book. Don't memorize this, but it was just interesting. It goes over the chemicals on the left-hand side and then their effectiveness on endospores. So poor to not very well. Okay, the next one on your list is aldehydes. And so we're talking formaldehyde and glutaraldehyde. Formaldehyde used to be used, it's not anymore because of carcinogenic fears, but it used to be used to preserve specimens used in high school and college science labs. So the cats or pigs or even just brains and eyeballs were preserved in a formaldehyde, but because of fear of cancer and high school students coming in contact with it and college students coming in contact with it, now they use a version that is not so bad, but you'll still hear people say that formaldehyde smell, but it's not actually formaldehyde anymore. Glutaraldehyde, you want to know, is a liquid sterilant. So several questions on the test, I'm going to say, which of the following is a sterilant? Which of the following is not a sterilant? So glutaraldehyde is a sterilant. Unless it says sterilant, it's not a sterilant on the notes. Kills vegetative cells in as little as 10 minutes, to only 2% of it, but still kills spores in 3 to 10 hours. Hydrogen peroxide and benzoyl peroxide. Hopefully we'll get to see today how well, or in the lab, how well the hydrogen peroxide works at killing bacteria. Also, benzoyl peroxide. Benzoyl peroxide is used in acne medication often. And then percetic acid is a liquid sterilant. Liquid remember, you want to know if it's a sterilant. Kills bacteria and algae in 5 minutes, and viruses and fungi in 30 minutes. It kills endospores because it is a sterilant. Kills endospores because it is a sterilant. Alright, that's it. Go back over these. You can watch them as many times as you would like to prepare for the exam.